In our digital world, we are just swimming in images. But what if I told you that some of them are hiding a secret? A secret so good, you literally can't trust your own eyes. Today, we're going to be digital detectives. Let's get into it.
I mean, just look at this picture. Take a really close look at the details. You can see the texture of the fur. The books are all soft and out of focus in the back. The light catches its eyes. It feels so real, right? This image was actually created with a pretty specific prompt, asking an AI for a realistic photo of a dog in a library.
So here's the question for you. I want you to make the call. Is this a real moment that some talented photographer captured, or is it something else entirely? Really think about it, because the answer shows just how blurry that line between what's real and what's fake has become.
Yeah, that dog, it never existed. And that library? Just a bunch of code, a digital dream. That whole image was generated by an AI. So if our eyes are this easy to fool, we're going to need a better tool. We have to look for the invisible clues, the ones hidden deep inside the pixels themselves.
You know, every single day, AI models like DALL-E and Stable Diffusion are getting scarily good at creating these photorealistic images from just a few words of text. They're so convincing that even people who know what to look for can get tripped up.
Well, here's the big idea that forensic experts are latching onto. They're not looking at what's in the image, the dog or the library. No, they're looking for an invisible signature that proves an image actually came from a physical camera.
And this invisible signature, it actually has a name. It's the key to this whole investigation. It's called photo response non-uniformity, or let's just call it PRNU for short.
Okay, so let's break that down because it sounds super technical, but the idea is actually pretty simple. Think about it like this. No two camera sensors are ever perfectly identical. There are these tiny microscopic flaws from when they're made, and that means each pixel reacts to light just a little bit differently. This creates a unique noise pattern across every single photo that camera takes. You can't avoid it. It is, for all intents and purposes, a fingerprint.
And what's really cool is we can actually see that fingerprint. So when we take a normal photo and process it just right to pull out its PRNU, this is what we get. It looks like a bunch of random, colorful TV static, right? But that static is anything but random. It's the unique, consistent fingerprint of the camera that took the picture. So if every real photograph has this physical fingerprint, what do you think happens when we run the exact same test on our AI-generated fakes? Well, this is where the whole case just breaks wide open.
I mean, logically, an AI image was never seen by a physical camera sensor, so it shouldn't have a PRNU pattern. But the complex math that goes into generating an image from scratch, all those different stages, it leaves behind its own kind of digital residue, its own little ghost in the machine.
And this just shows the difference perfectly. A real camera's fingerprint looks like random noise, but when we analyze our AI dog, we get something totally different. You can actually see the faint outlines of the dog inside the noise pattern. The process of creating it left these strange traces that actually mimic the image itself. It's wild.
So here's the real takeaway. When a forensic analyst looks at these patterns, the difference becomes crystal clear. Real photos have a noise pattern that's tied to a physical device. AI photos have artifacts that are tied to a mathematical process, and those artifacts just look, well, unnatural and structured.
Now these patterns are incredibly subtle. We can see the difference when they're blown up and put side by side like this, but trying to reliably spot them across millions of images online, that is a job for a machine. So it's time to bring in an AI detective to catch the AI fakes.
And that's exactly what researchers did. A human might be able to spot an obvious fake, but for the really sophisticated ones, you need a much more powerful tool. And it turns out, neural networks are amazing at learning to spot these tiny differences that are practically invisible to us.
To pull this off, they used a special kind of AI called a convolutional neural network, or CNN. Now, I know this diagram looks complicated, but the core idea is pretty straightforward. You can just think of the CNN as the brain of our digital detective. It's built specifically to look at images and learn to pick out those telltale features that separate a real camera's fingerprint from the weird, ghostly artifacts of an AI image.
So how good is it? Well, the results are pretty amazing. When they trained the CNN on these digital fingerprints, it hit a 95% accuracy rate using that PRNU method we talked about. And with a similar technique called error level analysis, which looks for weird differences in compression, it hit 98%.
But wait, it gets even better. When the researchers fed the system a much larger data set to learn from, its accuracy jumped to an incredible 99%. That is near-perfect detection. It means it can tell real from fake with almost total certainty.
A 99% success rate is fantastic, right? But so what? Why does this technology actually matter in the real world? Well, the applications are way more critical than you might think. This is not just some cool lab experiment. This is a vital tool for fighting misinformation and fake news. It's for verifying digital evidence that shows up in courtrooms. It's about protecting a photographer's copyright by proving an image came from their camera. And it's even for making sure our historical archives are authentic. Okay, so spotting a fake is one thing. But the next frontier for digital forensics is even more ambitious. Can we not only tell if an image is real, but also identify the exact model of camera that took it? And this gets really hard after an image has been squished and compressed by social media platforms.
And this is where things get a little tricky. This chart here is called a confusion matrix. It basically shows us where our AI detective gets, well, confused. You can see along the diagonal line it's mostly right, but if you look at that bottom right corner, you'll see the AI has a really hard time telling different Sony camera models from each other, probably because they share a lot of the same hardware and software. Which, of course, leads us to the final big question. We are in a constant technological arms race. Just as our detection methods get smarter, the AI generators are getting better and better at covering their tracks and creating more perfect fakes. So, in a future that's going to be filled with synthetic reality, the fight to figure out what's actually real, well, it's only just beginning.